you might like to see the Morris engine running after a few minor adjustments, and tighten up the crosshead, tighten up the eccentric, tighten up all the packing glands. You can hear the bevel gears on the governor make a little noise. It's raining out here right now. Hi, welcome to another old steam-powered machine shop. I got about 2.5 hours on the Morris. Had a couple of small issues with it. One thing is the set screw that holds the adjustment wedge on the bottom end of the rod for the bearings loosened up, or wasn't ever tight to begin with, I don't know, and it backed out and it was rubbing against the side of the crank cheek, and it actually locked up. Bang! I thought, man, this is not good. And I finally found that, cleaned up the threads, put that back in. It has a little more bottom end noise than I thought it would have. I don't really know what the problem is. I think this type crosshead, I don't really like this kind of crosshead because it's only got the slide on, it's only supported by the slide on one side, so it tends to rock back and forth, which just exaggerates problems. So I tightened it up a little bit and it helped. It's got to be tightened up some more. And also I'm going to take the rod brasses out and check them. The way they ended up, they were a little looser than I intended them to be. I wanted them at about 2,000ths, and I think they're like about 5 or 6. So I'm going to clean all the grease out of there and put a dial indicator on it and see if I can get a little play one way or the other, and I can take that up. But overall, I'm pretty happy with the way it runs. We got the lubricator on it and working. And in the shop this week, had a little project for a viewer who's restoring an old vise, a bench vise, and the screw was really worn out. It had been broken and welded once, and he wanted me to make a new screw for it. So rounded up a piece of stress-proof tool steel and machined it out of one piece, and had to cut a square thread on it. So I'll show you about that, and we'll get right to it. Thanks a lot. Appreciate your views and your likes and your subscriptions. Talk to you later. This is a hydrostatic lubricator that I'm sort of rebuilding, cleaning up for the Morris engine. And it's a Detroit lubricator, 1 pint size. And this is pretty typical of the kind of lubricators that were used in the early days of steam engines. They use them on pumps and anything that needed lubrication. And the idea here is there's a special kind of oil that's not made anymore except by specialty oil companies, but it's got a lot of tallow in it, and it somewhat mixes with the steam. This screws right into the steam line with a T, and it has a metering valve here, And in this glass, you see the little oil droplets going up through the water, and you can adjust it. And the way it works is that some of the steam condenses in the top in this dome. There's a steam line here that runs from here to here. So then of course the water goes to the bottom, which raises the oil up to the top. And you can adjust the water flow in and the oil flow out. And they work pretty well. Then when all the oil is used up, you can see the amount of oil you have. This sight glass here, I have to cut these to length, shows you how much oil there is left. And when it's out of oil, there's a drain on the bottom here that you open up, and it drains the water out. And after you shut it off from the system, drain the water out, you can refill it with oil in the top and then turn it back on again and start it back up without ever stopping the engine. I had to make a follow arrest for the American lathe because I never had one, and I had this threading job. It's a square thread and it's quite long and narrow, and I'm sure it's going to chatter if I don't have a follow arrest. So I'm taking time to make one. This is just a piece of 3/4 inch plate milled for some jaws. This is the piece I'm going to replicate. It's a vice screw, quite old. It's way undersized here. It's been broken and welded once. But I'm looking at this square thread, and I don't know if you could see it on this piece of paper when I roll it, but you know, when you're going to cut a thread that stops here, you got to figure out how you're going to end the thread. And this thread tapers off, and the root of it is angled. It's tapered down the first couple of threads. I don't know how they did that. It almost looks like they started the thread maybe with one tool that was tapered on the nose, and then finished it by coming in here or coming out here before the taper started up. It's kind of neat because it reduces the stress concentration here by having this come off at a taper. And I'm not going to try to duplicate that. I'm just going to run the thread up here, and within a half a thread I'm going to pull it off. I'm going to use a back gear to really low speed so I can see what I'm doing. This is a look at the follow arrest that I built the other day, and this is quite thin here. It's going to be 3/4 inch.
So I figured I was going to get in trouble with it, with chatter. Plus I have to cut a square thread on this. So I never had a steady rest, and this is it. Now the way this works is you make a small cut here, and then you set the steady rest to the cut that you just made, and then it follows along behind the tool and gives it a little support out here where it's thin. When I get to threading it, I won't need to move it because the OD won't change every cut. Built up the tips of the jaws here with brass, so it won't need a lot of lubrication, but it should have some, at least for a while. See, when you get down near the end here, it goes over the work, and it's just behind the cutting edge, so you can get right up to the shoulder. Okay. Well, I mic'd it. Very good surface finish, and it's about 1,000th over from this end. It's about 1,000th oversized to here, and about 1,500 oversized here. So I think that's the usual case where I've got to play around with shifting the tailstock a little bit to get it right. So if it's big on this end, I'm going to have to move the tailstock that way, away, just a little bit, like about maybe 1,500. I'll take another light cut across here and see if it helps it. But plus or minus 1,000 from one end to the other is well within reason on this one. Okay, so I set the tailstock over about 1,000. pretty happy with the way this works. No chatter at all. It chattered on me just one little bit right in the middle, and I think it was because the jaws actually got a little bit dry. So I've been putting oil on it ahead, but it manages to get it down to the lower level there. It's working pretty good. Square thread is really pretty simple. This is a 3/4 by 5 square thread. So in the distance of 1 inch, you got 5 threads. And if you divide the inch by 5, you get 200 for a pitch. So that's from this corner to this corner is 200. Everything is the same. On this one, the width of the tooth, width of the thread is 100 thousandths. The width of the groove is 100 thousandths. The depth of the thread is 100 thousandths. I mean, it's a square thread. You don't have to worry about any angles. You just feed the tool straight in, and with a lathe set up at 5 threads per inch. This is a square thread tool that I had. Somebody else ground it. I don't know if I'll use it. It's about 5 thousandths under width, but that's the idea. And you have to make it a little shaped like this. I don't know if I can do this to the camera. You have to give it a little bit of a, looking at it from the end, looking at it straight on from the end. The tooth needs to be shaped like this so that it won't drag on the side of the thread. And it also needs to be slanted a little bit more angle on this side than this side, so that this is at a little bit of an angle this way, which is supposed to match that angle. And there's a cool little formula where you can construct a little triangle to figure out what that angle is. But with a 3/4 inch diameter, the angle is so slight that it's almost negligible. So I'll get a tool ground up and show you how that goes. This is the tool. Piece of high-speed 3/8. Ground it to 100 thousandths wide here at the point. It's tapered back just a little bit. It's got a little angle this way, a little angle that way, a little more angle this way because of the angle of the thread. It's just very time consuming. Did it on the hand grinder, but that's what machine work is. You got to take your time and
make the fixtures and tools.
I'm going to set the box up on this lathe for 5 threads per inch. So the only 5 is on the 60/30 scale up here at the top, which means it's got a 60 tooth on the stud, which is back here, and a 30 tooth on the box, which is down here. And I switched those around already. So that's set up. So we're working on this part of the diagram. So 5 threads per inch, and you put the tumbler on that one, going on this column, and if you look over here it says set the handles at A, C. So that one's at A, that one's at C. I switched this one over from feeds to threads, so we should be good to go. Okay, we're all set up. I got the tool centered and lined up. I had to borrow the tool holder off the shaper, because all of the tool holders that I've been using here on this lathe are set up with an angle this way. They were actually made for high-speed steel stuff, so you didn't have to grind so much rake in the top of the tool. While they did make some that were straight for carbide tooling, carbide didn't need much rake, if any. But by the time they got around to doing that, these kind of tool holders were antiques. So there weren't very many of them made that way. I have one here, and as you can see, it's straight in. So I'm going to check, make sure that its gearing is set up right. And to do that, I'm not even going to scratch it. I'm just going to lay a marker along the side here and follow along on the piece. If it's off, it'll be a lot. Squeaking is this rubber belt that I'm using, rubbing against the side of the next pulley up. Nothing slipping, it's just the nature of the beast. Okay. Here's the mark. One, two, three, four, 5. Don't count the first one. 1, 2, 3, 4, 5. 5 threads per inch. This is the placard that goes on this lathe, but never got put back on. As you can read what it says here, it says for odd threads, like a 5, engage on every quarter revolution of the thread dial. So, I can engage it on any number or any line, but I gotta figure out which one it's gonna be. Am I gonna go the numbers or am I gonna go the lines? Gotta stay that way. So I'm gonna go the numbers. put it straight in, exactly 100,000. So I'm going to take This is a drill jig that I made in one of my earlier videos, and I use it quite a little bit for cross drilling shafts and things that the hole's got to get down right through the center line. And the way this works is there's a center hole drilled exactly between these two edges of this groove, and if you line it up in a drill press, I've got a 60-degree center going in a 60-degree center hole, and then tighten it up. Tighten up the table. It doesn't go in the center. Yeah. Okay. Now you can put V-blocks in here, and whatever you're drilling goes right exactly through the center. And in this case, it's the hole for the vice handle. See, will it make it? No, maybe not. I have to come back to this one. I need more holes here. Well, we definitely got steam. Drain the water out of the water catcher. Open the cylinder drains, and it's on top dead center.
repairs.